All right, guys, welcome back. And today we're going to be looking at evaluating functions. And so let's just get right into it. So we're used to writing functions as y equals, and then something involving x. But they can also be written as f of x equals some expression with x, and that just stands for function of x. For example, one we looked at in the previous lesson, f of x equals x minus 2 squared is the function that we looked at before. And so for evaluating them, we're going to look at a couple different ways. Evaluate each function at the given input. So remember, functions are all about inputs and outputs. So usually we consider x to be our input and y to be our output. And further down the line, if you look at like real world problems, sometimes you'll have t be the input. Like t usually represents time, but in this case, x is our input. And for reference, we have x as our input, and then f of x is going to be the output. So remember, we kind of just replaced y with f of x, and just like y was our output, f of x is going to be our output. And so the trick here, when I say something like find f of negative 4, since I replaced x, f of x here, with negative 4, I'm going to replace anywhere else I see an x in this equation with negative 4. So when I look at that, I'm going to write f of negative 4 equals negative, and then I see an x, so I'm going to insert negative 4 in parentheses, and then plus 4. So this ends up being f of negative 4 equals negative 4, which is the same thing as a positive 4 plus 4. So f of negative 4 equals 4 plus 4, which is 8. And that's our answer, right? F of negative 4 equals 8. And now doing the same thing down here, this time instead of f of x, we have g of x, just because we've already used f of x, and we should get used to using things other than f, even though f of x is common. G of x is also really common, so is something like h of x, and you could really use any letter you want to represent the function. But anyway, we have if g of x equals 5x plus 1, find g of 2. So again, I replaced that x with 2. So anywhere in this equation where I see x, I'm also going to replace it with 2. So we have 5 times x, or 5 times 2, plus 1. And so then we have g of 2 equals 5 times 2 is 10, plus 1. So then we get g of 2 equals 11. Pretty simple so far. And, now just to kick up the pressure a little bit, we're going to do the same thing. Now we want f of negative 4 for this function. So f of negative 4, wherever I see x, I'm going to put in negative 4. So we have negative, I see an x, so I'm going to put negative 4 in parentheses, and then squared minus 10. So now we have something that we have to be careful with, right? We have negative, and then negative 4 in parentheses squared negative 4 times negative 4 is going to be positive 16, but we still have that negative out front. So this is going to be negative 16. And then minus 10. And then f of negative 4. If we have negative 16 and we go back 10 more, we're going to end up with negative 26. And that's our answer there. And then same idea here. We have g of x, and we are looking for g of negative 5. So g of negative 5, I've replaced x with negative 5. So here, I'm going to, wherever I see an x, I'm going to replace it with negative 5. And keep everything else the same. And so now there's a couple things we have to take care of first, remembering PEMDAS, our order of operations. We have negative 5 squared. Negative 5 times negative 5 is going to be a positive 25. So we have 4 times positive 25. Plus a minus 5 is the same thing as minus 5, and then minus another 5. And now we can continue. So g of negative 5 equals 4 times 25. We can think quarters. 4 quarters is $1, so 100. minus 5 is the same thing as minus 10. So g of negative 5 equals 90, or 100 minus 10. And that would be our answer. Now, for these ones, we have to be careful what it's asking. So we're given f of x, and we're told to solve for x. So this one is different. And it tells us f of x equals 7. So remember the other ones, we had something like f of 7, right? And then we plug 7 in for x. But notice these two are different things. This is saying f of x is 7. The entire output f of x is 7. So when I see this, I'm not replacing x with 7, right? Because that x is still there. I'm replacing the entirety of f of x with 7. If f of x is 7, then looking at this equation, I can replace f of x with 7 since they're the same thing. So I'm going to do that. So 7 equals 5x plus 2. And now this is just an equation that we know how to solve. Subtract 2 from both sides, and we're left with 5 equals 5x. And then divide by 5, and we're going to be left with x. And then 5 divided by 5 isn't 0, but we have 1. And that would be our answer, x equals 1. So for h of x equals negative 2x minus 5, when h of x equals 9, so again, it gives us h of x. It doesn't tell us to find h of 5 or something. It tells us that h of x is 9. So I'm going to replace h of x with 9. And just like we left the x here, we leave the x in the equation. So we're going to add 5 over. 9 plus 5 is 14, and then we have, or not 14, sorry. Oh, wait, yes, it is. I'm crazy. I'm crazy. 14 equals negative 2x. And then divide by negative 2, right? 14 divided by negative 2 is 7. And then, if you like to write it the other way, x equals 7 is the same thing, and that is our answer. Negative 7, right? Divide by negative 2, we're going to get negative 7. And lastly, we're going to look at evaluating a function on a graph. So remember, x is our input. And f of x is our output. And that's also synonymous with y. Because notice here we have y equals f of x. So when we're looking for f of negative 4 on a graph, negative 4 is what's replaced with x, right? So this is, once the board comes back on, this right here is x. So we're going to look for x on negative 4. So this is the x-axis here. So we're going to go to negative 4. Here's negative 4. And now we need to find the output. And the output on this graph is right here, right? And so f of negative 4 is going to be, and then the output here is 5. So you find where your x is, and then you find where the y is on the graph. And then looking at some piecewise functions, it's asking us to find 3 different ones here. So we have f of negative 6, and it wants us to find f of negative 3, and lastly, it wants us to find f of 0. And so let's just go in order, right? F of negative 6, we're going to find negative 6 on the x's, which is here, and then we're going to go up, and right there we have a closed dot, and we are at y equals 4 there. So that'll be at 4, right? If we trace this over, that's at 4. And now it wants f of negative 3. So let's go over to -3, 1, 2, 3. Notice we have two open dots above here. Those two open dots mean that's not where the function is, right? Just like if we had an open dot on a number line, we're saying the function isn't there. But look down here, we actually have a closed dot right there. So that's actually the value of a function for this piecewise function. That's what they're called. They're called piecewise because they're kind of in pieces, right? We have this left piece and this right piece. And then it turns out right in the middle here, we have this dot down here. So f of -3 actually isn't defined there or there, but instead all the way down at -6. And then finally at f of 0, we're right here. And if you notice, we don't have anything. We have this open dot here, but that open dot isn't a closed dot. So we actually don't have a value defined at 0. And so what we write for that is undefined. Undefined. And that will wrap up evaluating functions both algebraically and graphically.